Hey, let's take a quick look at alpha beta pruning and we will do a very quick quiz. Okay, so the question we have is what value can be ignored, what value can be pruned, or in other terms, what value can be ignored. If you recall from the alpha beta pruning lecture, the thing that we should be thinking about is on what value can be not computed at all, not after we have these numbers. So we should change our mindset to say, okay, which value did I not even care about? So for that reason, let's cover all these numbers and now let's try to see, do we want to compute the values for these square boxes at the bottom or do we not? And the way to think about these ones is that try to put an extreme value in those boxes and does it change the value of the root or does it not? If it does not change the value of the root, and you can try with extreme values such as plus infinity, minus infinity. If it does not change the value of the root node, then you can ignore it. Don't even compute it. And if you see that it does change the value of the root, then you have to compute it. For example, let's start with the first node here. Do we want to compute it? Well, if all of these values are plus infinity, then these min nodes will become in plus infinity because the minimum of these two will still be that. And the ones taking the maximum of those two, you will have a high number here, such as like, let's not say plus infinity. Let's suppose they were all 1,000. So 1,000, 1,000. So minimum will be 1,000, 1,000, 1,000. This will be 1,000. So that'll be 1,000. Similarly, if all these numbers are minus 1,000, then this will be minus 1,000. This will be minus 1,000. So therefore, it does seem that we do need to compute this thing so we can get some idea about this. So let's go ahead and compute it. Now we get a 10 here. Now, can we now infer the value of the root node? Still not. If this does become minus 1,000 and this becomes minus 1,000 and these will, let's suppose they are minus 1,000, again this will become minus 1,000, versus if these are plus 1,000, plus 1,000, plus 1,000, this will become 10, but this will become 1,000 and then this one will become plus 1,000. So it seems we cannot get away without computing the value of the C node as well. Therefore, let us compute it. Okay. So you have to rationalize like that. Now, once you do have 10 and 8, then of course we can infer the value of this min node, which will be the minimum, and that's 8. Now we see, do we really want to compute the values of this? We know that the root node will be at least 8, but what happens if both of these values are 1,000 and 1,000? Then this will be 1,000, this will be 1,000. So it seems we still cannot infer the value of the root node. Therefore, let's go ahead and compute E as well. Now E is 4. Now we know that D will be less than equal to 4. Even if F is greater than 4, let's suppose it's plus 1,000, this will still be 4, and therefore this will still be 8. Let's suppose that this value is negative 1,000, this will be negative 1,000, and this will still be 8. So therefore, irrespective of the value of the F node, this will be 8. And that's the reasoning that we follow to say that this value is going to be less than equal to 4 and that the root node is going to be equal to 8. Therefore, we don't compute this at all. Okay. So this is a quick reminder about alpha beta pruning. We should reason which node we do not need to know about in terms of its value. We shouldn't think about, okay, we know the value so we can prune it, because if you know the value, that means we've already spent the time computing it. Okay. So again, let's remind ourselves that when using pruning, we will not even know that the value of the node F in fact was 50. If we were not using any pruning, then we would simply compute it 10, 8, that minimum is 8, compute this value of this node. However you're computing the value of the node, that's not what we're trying to argue here. However you're computing the value of the node, but irrespective of the value, once we have 4 and 50, this becomes 4, this becomes 8. In this case, there's no pruning. In this case, we do compute, we do use alpha beta pruning, so we just don't know the value of F at all. We don't know, is it 50, is it negative 50, but we still have the same root value computed. And of course, we saved 25% of the time because out of these 4 nodes, we did not compute 1 node at all. So that is a quick reminder, and that is one quiz about alpha beta pruning. what we can call is an easy quiz, and there's a mid-level quiz as well that you can find a link to. So go ahead and try that one as well.